Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera to all my students. I hope all of you are doing well. For today's lecture, we will cover about the chapter 1.1, which is the column chromatography. Okay, let's look at the first slide. Column chromatography is actually a technique in which the substances to be separated are introduced onto the top of a column. So inside the column, it was packed with an adsorbent, and then the adsorbent and also the mobile phase will pass through the column at different rates that depend on the affinity or the tendency of each substance for the adsorbent and for the solvent or the solvent mixture and um, usually collected will be separated, right? So I will show you some image of the column chromatography. So if you Google for the column chromatography, you can see this is the some picture of column chromatography. Okay, so usually we can handle it in the lab or in the R&D department. Okay, if you work in a R&D department, so the same instrument or the same apparatus will be used. Okay, column chromatography is commonly used to separate more complex mixture compared to paper chromatography and TLC. So the stationary phase or resin is packed in a column. The mobile phase will pass through the packed stationary phase to achieve the separation. So when the chromatography is carried out in column, it is called as the column chromatography. So it also called as a gravity chromatography. Okay, this is the chromatogram of the column chromatography. Okay, during the handling process of column chromatography, at first we introduce the solvent, which is the liquid, together with the substance that you want to separate. Okay, you must dissolve the substances into the solvent. Okay, and then maybe pour into the column. And then inside the solvent also have the adsorbate, we call it as adsorbate, which is a sample, right? And this is the column. Inside this column is called a silica bits. Okay, so the silica bits inside the column is a stationary phase, while the mobile phase is the adsorbate and also the solvent. Adsorbate containing solvent containing the adsorbate is the mobile phases. So after they are inside the column, the separation will be occurred. Okay, and the species or the component that elute first, it has less tendency toward the stationary phase, or we can say that it has high tendency toward mobile phase. So the separated component we call it as the elute. So some background information about the column chromatography. It is a mixture of components first dissolved in the mobile phase is introduced into the column. So the component will move depending upon their relative affinities or their tendency. Okay, so the stationary phase is the adsorbent packed in a glass column, while the mobile phase is the solvent or the eluent. Okay, so the stationary phase is adsorbent packed in a column containing a silica bits, and the solvent, which is the mobile phase, it will move slowly through the packed column. A solvent used as a mobile phase is called an eluent. So let's say if the question asks you what is the mobile phase for column, you can state a solvent or eluent. A compound attracted more strongly by the mobile phase will move rapidly through the column and elute from the column first. In contrast, a compound that have more strongly attracted to the stationary phase will move slowly through the column, right? So in column chromatography, the theory is same with the theory used in paper chromatography, whereby the compound that have high affinity toward the stationary phase, okay, high affinity toward the stationary phase, or we can say that it has strong attracted to the stationary phase. It will move slowly through the column and then it will elute last. Okay, it will come out last. All right, so don't get confused. I hope you can understand it very well. Some terminology in column chromatography. Stationary phase in column chromatography is called as an adsorbent, so it is a solid. And the mobile phase, it is also known as solvent and eluents, and it is a liquid form. For example, it is also known as adsorbate, which get adsorbed, and the elution is the process of removing the component from the column, and the elute is the separated component. So how the separation takes place? First, sample applied to top of the column. So we pour the sample together with the solvent on top of the column. So this column containing the silica beads stationary phase, and the flow is gravitational force. Follow the gravitational force, and as time increasing, so the separation of each compound will be separated according to their affinity and tendency toward the stationary phase and also towards the mobile phase. Okay, so the green component elute first and come out from the column first, and we can see that the column the green particle, the green component here, we show the chromatogram peak here, and the graph that the peak that appeared first at this chromatogram illustrated as the green component or green compound that separated first, and the second one is with this illustration, okay, in the middle of the column, and the last one is the blue one which is on the top of the column. It will separate the lastly. So the chromatogram is at the end of the peak, and the peak is at the end of the chromatogram. So this is the elution time, and this is a moment of the material. Okay. Okay, the principle in column chromatography, the mixture to be separated is dissolved in the mobile phase first, and the mobile phase is added through the column through the process. Okay, and the component will be separated according to their affinity, and this is the stationary phase which containing the silica beads, and each component is collected as it reach the bottom of the column. Okay, if we use the chromatography in types of instrument, for example, size exclusion chromatography. So this is the illustration or the principle used in size exclusion chromatography. We have a solvent reservoir. We also have a pump, a column, a detector, a fraction collector, and also the recorder. So this type of instrument is the principle of chromatography. For example, high performance chromatography, gas chromatography, size exclusion chromatography. Let's look at the types of column chromatography. We have partition chromatography, adsorption chromatography, gel permeation chromatography, and ion exchange chromatography. So these 4 types of chromatography we will cover in chapter 1.1. Let's look at the mechanism in adsorption. So adsorption is probably one of the oldest types of chromatography around. It utilizes a mobile liquid or gaseous phase that is adsorbed onto the surface of a stationary solid phase. So adsorb here not means that absorb. Absorb is syrup. Adsorb is means that it stick to the surface. Okay. So the equilibration between the mobile phase and the stationary phase accounts for the separation of different solute. We can see that the black particle here, it is a solute, which is solute adsorbed on surface of the stationary phase. The one that with the like the amoeba structure, amoeba illustration here is the stationary phase actually. So means that the sample you want to separate, it stick at the surface of the mobile of the stationary phase. Okay, so the separation occur when some, for example, this kind of illustration, the separation will occur when the substance that is stick to the stationary phase will be eluted last. Okay, for example, you can see that, and the light pink, which is the substance pink, it binds to the stationary phase more strongly compared to the blue particle or blue compound. So the blue compound here will be separated first, okay, because it not stick to the chromatography. So it has less tendency toward the stationary phase. Okay, this one is the stationary phase. Okay, so the blue particle, it has less tendency toward stationary phase. It also has less affinity toward the stationary phase, so it will be eluted first compared to the pink analyte. Okay, this pink analyte, it will bind more strongly toward the stationary phase, so it will spend more time in stationary phase and elute last. Okay, so this is the adsorption chromatography. Okay, the difference between the adsorption and absorption. For adsorption, it means that it stick to the surface, while for absorption, it dissolve. Okay, we absorb, they dissolve in the bulk. So there is a big difference between adsorption and absorption. Okay, the details of the adsorption process, it is a surface phenomenon when the stationary phase is solid. So mobile phase is liquid, or otherwise it can be gas. It is known as an adsorption chromatography. So please bear in your mind, each of the chromatography, it has a different stationary phase and mobile phase. So make sure you know the condition of the stationary phase and the mobile phase, whether liquid, solid or gas. So when a mixture of components dissolve in the mobile phase is introduced into the column, the individual components will move different shades depending upon their relative affinities. So the compound with lesser affinity toward the stationary phase will move faster, and it is eluted out of the column first. And the one with greater affinity toward the stationary phase will move slower down the column, and hence it is eluded later. Thus the compound are separated. So as we see in the previous slide, the blue compound, it has less affinity toward the stationary phase. That's why it is eluted out from the column first. We can also say that the blue compound, it has high affinity toward the mobile phase, and because the mobile phase and the compound is moving together. Okay, so it has a same meaning. Okay, we look at the illustration for A It has high affinity toward the stationary phase. That's why it is located at the top. And the C is separate first because it has less affinity toward stationary phase.